You open up your. I don't know how to make it.
Let me go over the calendar for this week as well as giving a big picture of what we can expect the rest of the semester. So the test is going to be on Friday. Okay, the test is going to be on Friday. I'll have a help session. I had a help session this morning, and I'll also have a help session tomorrow morning and Friday morning. Worksheet 3 is a little bit longer, so I think on Thursday we'll spend time going through worksheet 3. But I think it'd be good if you guys had some just daily practice getting ready. You know, I wanted to give you some additional time so that you're taking it and feeling comfortable with all the topics leading up to Friday. So it'd be good if you can work through worksheet 3, but you can also wait till I go through it with you or do it in class on Thursday, and then Friday morning I can have help session answering any questions that you have. If you're looking for additional practice beyond the test review, then I would suggest that you go back to your packet and work through some of the even problems. We worked through all the odd ones, so or because of time constraint, but you guys can go through and have some additional practice with the even number problems. So today and tomorrow and even a little bit on Wednesday, I'd like for us to start with this AP review packet, which is on Taylor series, which is great because you're getting the same content as what you're going to be tested over on Friday. It's just different format. This is FRQs. The ones that you're going to see on Friday is going to be more multiple choice format, but I'm still going to ask you for all your work to earn full credit. Okay. So the remaining grades that we have available, we have after this test and after we get into AP review, we're going to have 5 assessments. Okay. 2 of the assessment. So we're going to start off with a test grade. This will be just 2 FRQs. It'll be Taylor series and particle motion. And every one of these assessments, starting with this, as we get into AP review, will be buffered by your homework grade. So I'll be assigning homework on a daily basis, and I'll send you a reminder each day of what the homework is. And if you're doing your homework daily and showing it on time completely, then you're going to get the full 50 points for your homework. And then the other 50 points will be for your test grade. So you're getting 50 points of your test grade buffered by your homework grade. Now, if you're late for your homework, let's say you're late every day for your homework, but eventually you finish it, you'll still get, at worst, 40 out of 50 points. Okay. But ideally, you earn all 50 points just by doing your homework on time. So we're going to have a test over these FRQ. This will be next Friday. And then we're just going to work through a variety of, well, depending on which packet we're on, we're going to be working on packets leading up to spring break. And then after spring break, we'll have another FRQ, but it's FRQ quiz, just over 2 more topics. I think I'm going to make it polar and another topic, probably like differential equations. And then middle or late April, we'll have a multiple choice test. It'll be a 30-minute period doing AB content, and another day, 30-minute period going over doing BC content. And that will combine to be a test grade, but it'll also be buffered by your homework. There's also packets 5 and 6, And packet 5 is going to be a collection of FRQs from like the past 6 or 7 years. And then packet 6 is going to be a combination of just some miscellaneous problems and multiple choice tests. And these packets will individually stand as quiz grades, and it'll just be basically just completion. Okay, if you just do full completion grade, do full completion on packets 5 and 6, they will be both worth individual quiz grades. So, but they're pretty long, and so I want to make sure I give both packets to you before spring break so that you can kind of chip away at it. Especially for seniors, because seniors, your last day is May 9th. So want to make sure I give you enough time for you to complete all the packets. If for juniors and sophomores, you have until the end of the school year, so you have a little bit more time to complete. Yeah, so after this upcoming test, we have 5 more assessment grades. 2 in-class tests, 1 in-class quiz, and then 2 take-home quiz. And then you'll get to use calculators for all the assessments as well. Okay, so that's our plan for the rest of the semester. Any questions this time? Okay. So let's start off here. These are Taylor series FRQs from previous years. So you're kind of getting a taste as to, this is what number 6 could look like, over the past 30 years. And you're going to see some changes, but also some similarities over time. Yeah, so go ahead and start. The key is attached in your packet, but I want to kind of pace us through it. So yeah, spend some time just looking over it, and a lot of it you're going to hopefully feel familiar. But if you're stuck on something, then you guys can talk it over with people around you, but also you can also check the key as well. But I'll give you about 5-10 minutes to get started with it, and then I will go through each part with you before we move on to the next one.
Oh, whatever one my so. Thanks for the I think it's either one. Let's talk about. Yeah, she did.
So on my key, I built this from scratch, but this is centered about 0, so you could definitely use your knowledge of the Maclaurin expansion geometric series to build out your. Now, what you also need for part A is it's really helpful if you can also write out your general term, because if you can create a general term, then it's a lot easier to do your interval of convergence because you can just do your ratio test off of your general term. I think that's the most yeah, I think that's the thing with this type of problem that is most annoying. I think it's that you have to create your own general term before you can do your radius, your interval convergence. So, I mean, it's best, it's the easiest is when they give you a nice general term and you just build your interval convergence off of that, just do a ratio test. But having to create your own general term and then build your interval convergence off of that, I think that's the most, I think that's the thing that that yeah, I think it's the most difficult process. But you know, we've done all the heavy lifting with the quiz, right? We have all those general terms memorized, and so we can always build the general term off of one of those. So I built it from scratch, but I think it's a lot faster to um, just build it from the fact that your base of one is one, your common ratio is 2x, and you're just adding 2x to the previous term. And then if we just follow that pattern, it should be pretty easy to see that our general term is just quantity 2x to the n. So now that you have your general term, you can move on to part B, create your interval of convergence, going through your ratio test, and then testing the endpoints. But again, I worked through this using a much longer process, but we can just go through. Oh, and then as a reminder, all those formulas that we memorized, those are Maclaurin expansions. So if you have an e to the x that is centered at a different point, like x equals 5 or x equals 3, then you're kind of forced to have to go build it from scratch, build it from your Taylor polynomial. So those expansions that we memorized are just for Maclaurin, just for centered at 0. Yeah. So that's why we can do it here, because we do have a center of centering around 0. Both endpoints end up diverging. So our interval convergence is just between -1/2 and 1/2. Part C, go through your partial fraction method, your cover method. Break your rational function into two separate pieces. And if you can break them into two separate pieces, then you can just build each of them using your geometric series or power rule expansion. And then from there, you can combine like terms and gather your first four non-zero terms. Sorry, first five terms. So I'm just following geometric series here. A sub 1, my common ratio is 2x. Or I think what I did was I factored out the 2 first. I treated as 1 over minus 2x, but you can just go through and multiply with 2. You don't have to go through distributing 2 through. Yeah, you can easily just do it this way. Have a sub 1 being 2, your common ratio being your positive 2x. Build out your first few terms there, and then for your second, and build out your next few terms there.
On FRQ, will we have to say by test endeavors when we test? We test that point.
Let me check. I don't think you have to.
Multiply to get the same thing, or is there something that's not?
You have to partial fraction. Partial fraction. So we have to break it up into, oh, you're saying multiply through. Well, they want you to use partial fractions. So you want to break it up into the sum of two terms. But I think technically you could multiply through and get the same answer, but you wouldn't get full credit since they want you to use partial fraction. Yeah. on the key, they tested the endpoints, but they didn't specify the name of the convergence test, so you don't have to say it. But our reasoning would be end term test, right?
Yes.
Okay, if you're good with one, go to number two. Yeah, so when they say justify your answer, then you definitely need to say your reasoning for how you know your endpoints either converge or average. Yeah, start off with the ratio test.
Yes, it is.
What letter is this?
It's an X.
This is N, X.
It's an X. This is an X.
Both are being written.
This is an X. And this is an X. There's something like this. That's not this. Look how they like their X.
I think.
Yeah, that's I write it like they type it.
That's a lot different. Set the spark in this. Not this one. So now we just multiply. Get X by 3. What about my shot? Oh, Ellen. Chill, I'm just a little lost. Yeah.
Bro,
Wait, wait, you're more influenced.
Wait, what?
Nothing else required to be racist on my own time.
Your own?
I am Asian. So. No, no,
I don't know, one way or another. I love BCT.
It was too over.
Yeah, that
it's one.
Yeah, look at the
They just put it all at one.
You see. I'm gonna get out.
Oh, it's the limit. 90. It's the limit. Max equals 1.
Yeah. What is the next question?
Thursday would make sense for next time.
We don't even have like.
Yeah.
What pieces are we even playing?
It takes separate limits.
I'm gonna finalize that.
Yeah. Like half of it, but.
It used to be my big four.
So I went to the. I just be making Jaya. Like to have it every day is insane. Like after like.
I don't know, I wasn't there.
Might as well just like set mine on fire. It's like it's good. Just make it just
Just get it.
Shoot, bro, I just have a
Oh,
call.
Brenda.
I'll like how many shots. Like.
That's not. Which I.
If I was race hero, then I would have said he's
Get rid of both LMs. There's two X listed.
Josh looks great.
the rice in the bag.
September.
With the rice in the bag.
You know, he said. Yeah.
You like yelling at.
I don't know if we're good.
Yeah, that's why I said second.
With the Indian?
I said second song.
You were saying he's
Obviously, you could not put it.
No, we should, if we do get our.
You know.
I never know if they're gonna get stuck down to it, but I don't know how you tell. Yeah, you can learn it.
Yeah, I'd rather eat sandwich.
I've never.
At the same time.
I know, we also don't have the base player.
It's not a hard problem, I'm just like.
If it's a real good, it's cute. Yeah,
This is-
or else.
My-
No, I do.
That's good.
No.
Go, turn it EA.
Should we?
I just wanna go home.
I do it in seven.
But we don't need for a living, but like already.
Get on my level, I do it.
Well, it's the same. Isn't there? Oh, I thought it was like. Yeah, bro, we should play Lip Live. Busy got there, right?
Do you know,
That's like-
this running it was actually fake. I can't.
No, wait.
Is this a
Yeah.
trust
I
thing?
legitimately.
Yeah, I know.
Like, on set.
Yeah.
Like very
Well, I think, yeah, but like as long as it matches the like
Oh, shit.
convergence or that.
I don't know how to hear it.
Like, if you compare it to divergence and.
Like-
Oh, you're drawing hyperpigmentation.
I like how they say this limit up here and call it 1.
Yeah, but.
Yes, that's like.
I get it.
I get it, I get it, I get it, I get it, I get it. I get it, I get it. Yeah, but you're above. You never show up to the. That's why. But like, I feel like I would still want to use this. Because I've been like watching the lectures, and it's don't.
I feel like this is gonna be like, this is like next week. But this, but the AP exams, it's just on Academy all day.
Oh, never mind. I thought I understood it. I was gonna say I understand it now. I don't understand it now.
Yeah, they didn't give a short answer.
I'm going on the step.
Yeah. Yeah, I don't want to do that.
Okay, so after ratio tests, we see our potential interval convergence between -1/2 and 1/2. And then we can plug 1/2 and -1/2 into each of your rule sequence. This one, plugging in 1/2 into the original one, we see it's 1 over natural log of k plus 2, which we know will diverge by harmonic series, since we know that 1 over k plus 2 is going to be diverging by harmonic series. So we're going to use, this one is more of a direct comparison test, since it's hard to find a good fit for that natural log of k plus 2. Yeah, anything that is smaller in the denominator is going to end up being larger overall. And then for when I plug in -1/2, I get -1 to the k over natural log k plus 2. Now this does converge by alternate series test, because all we need is that 1 over natural log of k plus 2 to approach 0, and it does. So converges at -1/2, and then diverges at 1/2. Hey, by the way, your homework is going to be pages 1 through 6, so that's what I'll be checking tomorrow. So I think we should get through half of it by the end of class today. So if we go to next period.
It's like bottom of zero. That's must be public, but I thought that you were also. Yeah, so I was thinking about video. I took that also. So you're supposed to, I didn't go to the right answer. Yeah, I think doing that, just this good. So like, I so when fairly cute, like, I never hear. Oh, sure. All these. It's not what. It's here. It's not bad. It's yeah. That's the name of it. It's not how
Hey, page 3. For part A, I just built it from scratch. You could get it into that geometric power series form, but it takes a little bit of kind of rearranging and getting that. I don't know if it's you could, but I don't think it's too bad just to build it from scratch. But we could turn that 1 over x minus 1 into an a sub 1 over 1 minus r. And then from there, we can build out our terms as well. So you have two options for part A. For part B, it says use the result from part A to find the first four terms of the series expansion about x equals 2 for natural log of x minus 1. So the relationship between 1 over x minus 1 and natural log is we know the antiderivative of 1 over x minus 1 will turn into natural log of x minus 1. So we can just take our function here, just know that this is basically at the derivative level of the natural log of x minus 1. Just go through power rule, and this will bring us up to the natural log of x minus 1. I do want to walk through part B here. We know that each term will go through power rule, right? So 1 becomes x minus 2 becomes x minus 2 squared over 2, x minus 2 squared becomes x minus 2 cubed over 3, so on and so forth. We get to our general term. Now there's also plus c here, right? And when x equals 2, when x equals 2, we can plug 2 in for all the x's, and that will allow us to solve for c. So if I plug 2 in for x, I get natural log of 1, which is 0. This becomes 2. Everything else zeroes out. And I can solve for c, so c equals -2. And so we can put that -2 with this x and make it x minus 2 to make it look a little bit cleaner. So technically, this -2 is a plus c that's been rearranged to put with that x minus 2. Hey, we talked about how with these FRQ problems, part C, last part is always a bit more challenging, always a little bit more involved. But at the same time, I don't want you to be discouraged by the last part because it's always like, hey, you just want to just earn as many points as you can. If you can get 2/3 of the FRQ for each problem, you're in pretty good shape. And getting that last part is just like bonus. Right? So it's not like, oh, I can't get part C. I'm going to do terrible. It's more like, you just try to do what you can, but just understand that sometimes it can be a little bit more challenging. So part C says, use a series to compute a number that differs from natural log of 3/2. So natural log of 3/2 would be when x is equal to 5/2, right? Because 5/2 minus 2/2 will end up being natural log of 3/2. So we're trying to figure out basically when x is 5/2, what can we say is a partial sum that will give us an error that is less than 0.05. So we basically just have to look for the first unused term that is less than 0.05, right? So we can just take 5/2 and put it in for our rule of sequence. So 5/2 minus 2 would be 1/2. 5/2 minus 2 squared over 2 would be 1/8. 5/2 minus 2 cubed over 3 will be 1/24. And we see that 1/24 is the first term that gives us a value that is less than 0.05. And so therefore, the partial sum that we're looking for is 1/2 minus 1/8. We know that S of 2 will produce an error that is less than 0.05 because that first unused term, 1/24, is less than 1/20. So the actual value of natural log of 3/2 compared with the partial sum S of 2 is off by no more than 0.05 because we know that 1/24 is safely under that error. I think what adds to the challenge of this problem is, having to do this without a calculator on the AP exam. So. All right, can we start number 4 for a few minutes before we stop? Yeah, practice writing out that general term. That's the part that you'll probably enjoy the least about these problems, having to create that general term. Okay, so your homework, pages 1 through 6. So starting with this homework, you're earning points towards your quiz. Okay, you're earning points towards your AP, your AP assessment. This case will be the test. So I'll send out a reminder each day for the homework that's due, and you guys have a key attached. So you just have to work through these problems in full to get full credit, earning your points towards your assessments. Okay, all right, come get your phones.
Finish my annotated bits, great, piece that way. I'll let you. Zero. Lucky to start in the day. When we do votes, Jackie's. Oh, if I don't get it today, at least something I do now.
Tonight, I'm still.